Hello everyone, Assalamu alaikum. So I'm back with another video for an introduction to deep learning. Okay, let's now talk about three broad categories of machine learning. So the three broad categories of machine learning are supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning? Supervised learning is, I would say, the most common form of machine learning or deep learning. So supervised learning is the biggest subcategory and it involves labeled data. So if you recall the spam classification example, that would be one example of a supervised problem where we want to predict whether an email is spam or not spam. And the labeled data are then examples of spam and non-spam email. And it also involves direct feedback. So you can say whether our prediction was correct or not, basically. So you have an example of an email that is spam or not spam. The model does the prediction, and if you let's say during evaluation know the correct label, you have the direct feedback here during the training. We will talk about this a little bit more. So let me just briefly go over the three categories, and then I will talk about supervised learning and the other two as well. So unsupervised learning is in contrast to supervised learning, not involving any labeled data. So here we don't have labels or targets, and we also then don't have feedback. So we assign, for example, a group. To give an example, for example, in clustering we have cluster memberships, but we don't have any feedback here. So it's more really about finding a hidden structure in the data. Reinforcement learning is the third category of machine learning, and here this is more about learning a decision process. So think about the example of self-driving car. So the process of driving the car is like making multiple decisions. It's like the goal here might be to arrive at a destination, but to get there you have to make a lot of decisions, like stopping at a red street light or turning around the corner and so forth. So here what we do is we employ in a reward system that rewards the agent for making correct choices. And it's not like predicting a single outcome or something. It's more about learning a series of actions like steering the car through difficult environment. And there are some examples where you can actually use supervised learning for self-driving cars too. For example, recognizing the street light itself, right? Uh, could be involving convolution networks, for example. But the process here is more like learning a series of actions. We won't be talking about reinforcement learning though. It's kind of out of the scope right now. Nowadays you can also use deep learning for reinforcement learning, that is usually known as deep q learning. But yeah, this is really not in the scope of this content. So here we will be focused more on supervised and unsupervised learning, as you have seen from the introductory slides where I showed you the topics. We already have plenty of things to talk about. So a little bit more about supervised learning. Supervised learning, like I said, is the largest subcategory of machine learning, which is focused on labeled data. And you may already be familiar with regression. So here is just a sketch of a linear regression model, and here how this works is it's just an example with one observational input, or we can call that in machine learning feature. So our x variable, the explanatory variable, we call that the feature, and the target here, the dependent variable, that would be our y-axis or the data on the y-axis here. And here we are fitting a linear model. So we, for example, can then predict, if we have a new observation, what its target value might be given this model. So there is these x's here, the training data. Think of it as the training data, and now think of it as let's say I have a new data point, that is, let's just say here that say that it is here. So this is my input. I only know the value of x. So I know this x value. To predict the y value, I would go up here and then look up the y value here. So using this linear model, I can make predictions for new data points for this one here, which is not in my data set. It would be one example of supervised learning problem. Another example of supervised learning is classification, and actually classification is much more common than regression. If you look at literature and deep learning, so most systems are focused on classifications. For example, recognizing objects and images, like is it a cat or a dog or something like that. So we will see a lot of examples of classification also. Or if you think back to the ATM machine that I showed you earlier, where it was recognizing these handwritten digits, it was recognizing or classifying these digits. So whether it's a 2 or 3 or 4 and so forth. Here's an example of a binary classification problem where we only have two possible labels. One possible label is the minus sign and one is the plus sign. So the labels here, either the minus sign or the plus sign here, may maybe there are two possible labels. It's just for the sake of simplicity. And here I have two features, x1 and x2, and the goal is to predict for a new data point whether it's a plus or minus. So if I have for example new data point that is located somewhere like here, because it's on the left side of the decision boundary, so this is a linear decision boundary learned by this machine learning system, it would predict a minus sign, and everything on the right hand side would be predicted as a plus sign, for example. So we will see more examples of that, but here the goal here is to learn a decision boundary. So that's the goal in classification. And here this is the linear decision boundary, but it can also be a complex decision boundary. It could be like something more complex, curves or something like that. And deep learning or deep neural networks are actually learning very complex decision boundaries. And also in practice, when we have real world data, we really only sorry only have two features. We usually have very high dimensional data, so we can't easily visualize it, but that is it's just like an overview of a very simple case of classification, so that you know that two different types of supervised learning, regression and classification. And to make more things more interesting, there's actually a third type, which is also known as ordinal regression or ordinal classification. So ordinal regression is very similar to classification, but there is a rank order. So we have ranks that we want to predict. Think of it as for example as movie ratings, like great is better than good, which is better than okay, which is better than for genre fans, and which is better than bad. So there's a ranking. So these are classes. You can actually use a classifier to classify, let's say, a written text or a movie into these classes, whether it's great, good, okay movie. But here you have additional information. You have like the ordering information among the labels. So there's a little bit more information about that. So it's also called ordinal classification or ordinal regression. And here is another example, like with actually two types of subproblems. One is ranking and one is ordinal regression. So ranking is closely related to ordinal regression, but it's a little bit different, because here it's more about predicting the correct order. We don't really care so much about the correct label, because this is just my personal ranking. So from I would say favorite to least favorite, because you probably never heard of these movies, maybe, I don't know. Let me take a simple example here. So these are cups in different sizes, and if you don't know the size of the cup, if you only have a word to describe it, like small, medium, large, well, they have specific names, but I forgot them. Let's say you have these cups, you don't know the exact sizes. This would be like ordering problem where you want to order them from small to large, or an order regression problem. You go to a little bit beyond just ranking. You also want to predict the correct label. For example, when we use the coral networks, we use an age dataset as an example because we have large face images uh, available. And in deep learning, we use convolution networks. These are particularly good for image data. So it is a good example for demonstrating this auto-regression network. So here the task was predicting the age. So the age also has ordering information. You might wonder why don't you use regular regression for that? You can think of it also as a non-stationary problem, or it's just like the difference. Let's say between a 6 and 10-year-old person is much bigger. Let's say between 6 and 10 years, it's just 4 years. The difference might be much bigger than the difference of a person, let's say between uh, say 70 and 74. It's also only 4 years here for but just have to imagine, for a 70 to 74-year person, it may be different. Maybe the differences are mostly defined by how the skin looks like wrinkles and the things like that, but it's only maybe a slight difference between 70 and 74. Here between the age 6 and 10 person might grow a lot like child. um, he or she might be a much larger, for example, or the feature for the face changes more, and things like that. So I hope you get my point in this. So comparing these two age differences is kind of unfair, like comparing the age gap between 70 and 74 and the age gap between 6 and 10. Both have 4 years difference, but if you get the essence, they are actually very different. The buildup is totally different. So and in that way, metric regression treats all the values at the same. It wouldn't be really a good idea to use metric regression. I mean, you can, but I think ordinal regression would be a more natural choice here, where you don't have defined differences that are not on the metric scale, for example. But also in this course, we won't talk about ordinal regression really. We will be mostly focused on classification for supervised learning. So I just wanted to cover this for the sake of completeness, because there are three categories really, like classification, regression, and ordinal regression in supervised learning. So in the next video, I will then talk more about unsupervised learning and also briefly about reinforcement learning. So if you have any questions, then you can leave a comment below. Till next video, take care.